on the ground an hour or more. These so-called long-track supertwisters aren't confined to Tornado Alley. In 2002, one paid a sudden and unwelcome visit to a small town on the East Coast.
It's coming this way, guys.
Yeah. Here it goes. I'm leaving.
I remember seeing this huge funnel cloud. And it was holding things in the air that were just whirling so fast. And as they came to the top, you could recognize things like a tree, a couch, a desk.
You're expected to have to take cover immediately.
And we're looking at each other thinking, is that a tornado? Where's it going?
It was a supertwister, sweeping straight through the center of La Plata, Maryland.
Then I remember this tangled mass of metal was coming right at me. I mean, directly at my car. And briefly I thought, oh, I'll probably get decapitated. And my car lifted 2 feet up in the air and actually moved under the CVS sign.
Still, I say it sounded more like a jet turbine engine. I can't even duplicate the sound. And the house started rumbling, shaking.
The giant vortex sped through town.
This tornado was moving at close to 60 miles an hour. That's a mile a minute. From here over to the buildings that are standing there, the tornado was probably through here in 15 seconds or less. 1 minute everything is there, and then 15 seconds or less, everything's destroyed. It's amazing. You go from almost no wind up to 200-mile-an-hour wind and back down.
As the tornado was ripping through downtown La Plata, just outside of town, Susan Erickson and her husband Eric were visiting the construction site of their new dream house. They had no idea a tornado was coming.
The only thing we had heard on the news that day was thunderstorms. And we had thought, no big deal. We had just come up from the basement. I remember silence. At that time, no birds, no anything. I just heard silence. We were getting ready to leave, and then everything went blank.
Susan came to in a pile of rubble, hearing the groans of her husband, Eric.
Both my arms were broke. They weren't functioning correctly. So what I did was try to maneuver my legs so that I could stand up and drag my arms up with me. I remember walking out of the house.
Luckily, some neighbors found Susan before she passed out again. The next thing she knew, she was in the hospital.
It was between the 2 surgeries, before I went in for my orthopedic surgery on my arms, that they told me he had died. They said he was in a morgue in Baltimore.
Eric Erickson was one of 5 people killed by the supertwister that hit La Plata. Far from Tornado Alley, the monster storm carved a path of destruction 62 miles long, narrowly averting an unthinkable disaster.
If you would have taken the La Plata, Maryland tornado and just moved it north about 30 or 40 miles, you would have gone from beltway to beltway, right across the Potomac and through the nation's capital.
Rare as they are, supertwisters can strike anywhere, anytime. But no one knows why. In fact, scientists are stumped about what causes any tornado, large or small. Unless they can solve the puzzle and figure out how a supercell thunderstorm creates a tornado, then predicting supertwisters will be impossible. But how do you decipher the inner workings of a tornado?
Meteorology, in contrast to chemistry or biology, is not a good laboratory science. We can't produce an accurate representation, a controlled representation of a thunderstorm and change the variables one by one to make tornadoes.
No one can create a real tornado, either on the plains or in a lab. But there is one place where scientists can play puppeteer with the weather: in a computer.
The closest approximation we have are computer simulations, and we try to build a digital computational model of the tornado and see if we can change variables and have storms that produce tornadoes and ones that don't.
One of the leaders in tornado computer modeling is Lou Wicker.
It doesn't have good rotation. We're not going to deploy. Cyclone data?
20 years ago, Lou was a young and eager storm chaser, tracking tornadoes the old-fashioned way, on the open plains.
Let's move. Let's go. We're moving west. A little farther, Steve. A little farther. Peek the hill. Peek the hill.
Back then, researchers thought the best way to learn about a tornado was to leave special sensors in its path. That was the idea behind Toto, a weather station the size of an oil drum. Lou took charge of getting Toto as close as possible to a tornado without wiping out the research team.
Let's go, let's go, let's go!
Well, in the 70s and the early 80s, we're just trying to understand what made storms work sort of visually. Now we're moving into an era where we're trying to understand the dynamics of storms. Inside storms, dynamics means how the individual blobs of air are all interacting with each other to produce the flow that becomes either the strong winds or even the tornado or even the things that produce hail.
Based on years of weather research, Lou produces an amazingly detailed computer simulation designed with scientists at the University of Illinois. It reveals a familiar pattern. A thunderstorm explodes into the atmosphere, growing more intense every minute. The clouds begin to spin and roil high in the sky. They descend closer to the ground, still swirling rapidly. Suddenly, the rotation narrows and intensifies and touches down to Earth. The question on everyone's mind is, what triggers that final step? What makes the tornado form?
Somehow, supercell thunderstorms are able to bring intense rotation and intensify that rotation near the surface. And we don't understand that process very well. We know that before a tornado forms, there are areas of rotation in the thunderstorm. What we don't understand is how that rotation is brought down to the ground and intensified in a very short period of time in order to make a tornado.
In the search for a trigger, one of the primary suspects has been a burst of air descending from the storm, called a downdraft. The idea is that the downdraft wraps around the storm, tightening and intensifying the rotation.
We think the downdraft is really important for producing the tornado because it helps sort of squeeze the air from near the ground up into the updraft. The air wraps around and sort of the downdraft kind of comes around and squeezes the air in the front and the back together to kind of squirt the air up off the ground.
In the minutes before a twister forms, storm chasers often see a downdraft blasting a hole in the clouds toward the rear of the storm.
Well, it's a very impressive storm. So far, there's still no tornado. But the structure looks quite good. We're seeing a very strong RFD coming down. On the radar, it's still looking pretty good.
But just as often, a tornado fails to materialize. There must be more to the story.
It's very likely that in order to solve the tornado problem, we're going to need a lot more data than we have right now because a lot of things are going on at very small scales that we don't actually sample. And so until we have that, it will remain a research problem.
And so, every spring, storm chasers like Howie Bluestein hit the roads of Tornado Alley, all on the hunt for the tornado trigger.